did what would equal 14, like 7 squared, and then 16 would be 4 squared.
Oh, I see what you're saying. No, it's find the square of the number. That means you're going to square the number. Okay? 14 squared. What you're talking about, Amelia, is square root. And we're going to get to that. Okay? 16 squared is 16 times 16, which is 256. Okay? This one here. If you didn't get it right, here's what I did. I did 5 divided by 6 was 0.83. What's that line mean on top? I actually wrote it wrong. Does anybody know what I did wrong there? Kendall. It's 0.83. The line should just be over the 3, because the 3 is repeating.
So that would mean it's 0.83.
Right, yeah. And this is actually a smaller number than 0.84, if you think about the number line. Okay? All right, here. A square room has a side length of 25 feet. What's its area? Now remember, if you have a square room, that means the sides are all the same length, correct? And to find area, you do length times width, because area is the stuff inside here, correct? Length times width is 25 times 25, which is 625 feet squared. Cool? Okay. Let's write some definitions here. Square root. I get a little bit to fill in here, so don't write too big. This is the official definition. If b squared equals a, so like if 2 squared equaled 4, is what they're saying, then b is the square root of a. Now I'm going to make you draw a little picture here just to kind of clarify what they're talking about. If you want to, you have to get caught up. The word square. What's a square? Let's draw a picture of a square here. It is. So if I'm going to make my side length b here, okay, how do I find the area? B times B equals A, right? B times B equals A, which can be written as B squared. So these are the roots, the square root of A. That's what they mean by that. It's the square root. It's what the side length of the square is, if you want to think of it like that. What number times itself gives me A? All right, so tell me, what's the square root of 4? Why do you know that? 2 times 2 is 4. What's the square root of 16? 4, which is 4 times 4 equals 16, right? All right, radicand. This is a word you might hear. Am I going to test you on knowing it? Maybe, maybe not. Probably not, but it's a word you're going to hear. So if you have the square root of A is the radicand, the number under the square root symbol. I abbreviated square root symbol, which is actually called the radical, but that's okay. A is the radicand, the number under the square root symbol. Okay, perfect square. Does anybody know what that is? All right, make a list. Not too big. 2 times 2 equals 4. 3 times 3 equals 9. 4 times 4 equals what?
16.
5 times 5 equals 25. I could totally keep going with this list. These numbers here, and continued, those are perfect squares. Because what do you think, Kendra? Something about their square roots.
Yeah.
What about their square roots? Perfect. All of these numbers, their square roots are integers. That's why I reviewed that word integer. It could be negative, right? It could be negative 2 times negative 2. That works. So they're perfect squares. I'm going to abbreviate because BC. Their roots are integers, not decimals. Okay, on your calculator, do the square root of 5. Is 5 a perfect square?
No.
Why not? Because its root is a decimal. Okay? How about 169? Is that a perfect square? Yes, because its root is what? 13, an integer. Okay, make sense? Okay. All right, evaluate the expression. Does anybody know what the square root of 10 is? Yes, it's 10, and when this is outside, that means you just make your answer positive or negative 10. 10 or negative 10. Okay? How about the square root of 121? Yep, just 11. We're just going to use 11. If it says outside, you put both versions. There's a lot more to that, but for now we're just going to consider the positive version when you're doing that. Okay, try the square root of negative 400 on your calculator. What does it tell you? What does that mean to you? Yeah, in your realm of numbers right now, you cannot take the square root of a negative number. But when you get to Algebra 2, you will be able to. Those are imaginary numbers. But for now, you can't take square root of a negative number.
Can you just say NA?
You could say NA, a negative number. Okay? Yes, Brittany.
So what is like the positive or negative on the 100?
Well, after you take the square root of 100, I want you to list the positive and negative version because it's outside. That's what that means.
Okay.
You want to make it a positive 10
Oh.
and a negative 10. Because really, isn't negative 10 times negative 10 100 also?
Mm-hmm.
Yeah.
Oh, okay.
So it wants you to list both of those versions. Okay? Yes, Amelia.
If it had a negative outside of the 400, but the 400% said positive,
Could do that.
would you just do 400 in the calculator, but then just add a negative?
And your answer would be negative 20.
Okay.
It's asking for the negative root of 400. Yeah. Okay? All right, so I want you to add this word here because otherwise it's not going to work. Square. The top of a square box. Has an area of 320 square inches. Okay, so I'm going to draw myself a picture. We're saying that this part inside here has an area of 320 square inches. And it's a square. How would I find this area? What would I, if I could, what would I do? Yeah.
Would you take the inside area and divide it by the sides?
It's close. Because you're very close.
Oh, wait, you
How do you, just tell me in words, how do you find the area of a square normally? Length times width, right? Stay with me, Kendall. I think I know you know, but I don't know what these are, do they? But I can assign them a variable. Let's say this is x. If that's x, this is x, correct?
Mm-hmm.
Okay, can I write an equation for the area? Area equals length times width, x times x, and what is my area?
at 320.
320. Now you might see where I'm going here. How do you write x times x?
X squared.
Okay? Stop a second. How do you undo multiplication in an equation? What's the opposite of divide? How do you undo addition? Subtract. Well, I need to undo squaring. How do you think you undo squaring? Anybody know? Don't divide. It's tempting. It's tempting to divide by 2, but that's not what you do.
Square.
Do anybody know what the opposite of squaring might be? Thank you, Parker. Okay, you undo squaring by taking the square root. And I'll show you what that looks like here. So just for clarity, I'm going to rewrite this, and then I'm going to show you that I'm going to take the square root of both sides. Have you seen this before? What happens here is that squaring and square root cancel each other out, and you're left with just x here. So x equals whatever this number is. Take the square root of 320. 17.9, and it keeps going, doesn't it? Yeah? So I'm going to say approximately 17.9 inches. If you don't know, I can show you later. Key point here is this. To undo squaring, you take the square root. Like multiply, opposite is divide. Add, the opposite subtract. Opposite of squaring is what?
Square root.
Yep, got it. What's the opposite of square root? Squaring. Okay? All right, turn it over.
What would you do if it was a star square?
You can still do it, but we'll get to that later. Okay? All right, on the back here, I want you to draw, not too big, I want you to write real numbers along the top. We're classifying numbers here. If you've never seen this before, this is the symbol for real numbers. Have you seen that? It's kind of like the paragraph symbol. You might, when you go up into upper level math, you'll see that eventually. That's the symbol for real numbers. It's kind of like, yeah, it's like you do 2 lines and then you draw a big R. Okay? Now, we have 2 types of numbers you guys are working with. So draw like not too low, 2 little lines like that. And then a big circle here. Big circle. This one can be smaller. And on the top of this one, I want you to write rational numbers. And on the top of this one, I want you to write irrational. Got 2 types of numbers that are involved in real numbers. Okay, over to the side. Irrational. Well, then let's just do this. Draw a kind of a small circle and then draw another circle kind of around that. This is like a Venn diagram. Have you heard of Venn diagrams before? Sort of like a Venn diagram. Inside the little tiny circle, I want you to write whole numbers. Whole numbers. Whole numbers are rational numbers and are real numbers. And they are like your counting numbers, like we usually use to count. We don't usually use negative numbers when we're counting, do we? Okay, so it's like, we include 0. It's like 5, 16, 1, 2, 3, 4. Those are whole numbers. No negatives. Then we're going to jump to integers. Whole numbers are also integers. Or integers include the whole numbers. Let me say it that way.
No.
Integers include whole numbers. And what did we decide an integer was? It's these and their negatives, right? So -1's an integer, 21, 1, -21, 3, -14, 5, -5. No decimals.
I was about to write -0.
So integers include whole numbers. And then there's one number, set of numbers we're not including in these 2, and it's the decimals. The decimals that don't, that repeat. Let's say they repeat or they end. They repeat or they end. Okay, so let's say 3/4. What is that as a decimal? Does anybody know?
Like
0.75. That's a rational number. What's this as a decimal? It's repeating, right? Repeating decimals are rational numbers, so I'm going to write it like that.
Wouldn't it be negative though?
Negative. Thank you. Negative 0.3 repeating. Okay, so this is all the rational numbers. Okay, they include integers and whole numbers, and they're all, so anything that's not rational is what? Irrational. Can you give me a number that is irrational, that doesn't repeat, and it goes forever?
Pi.
Pi is the perfect irrational number. Look at the poster. Goes forever. Doesn't ever stop. That's pi. Okay? So you might want to write no repeating pattern. In the decimal, and it's non-terminating. What does non-terminating mean? Doesn't stop. On your calculator, do the square root of 2. Square root of 2. The square root of 2. It kind of goes forever, doesn't it? Let me show you what it looks like here. So your calculator can only go, if you have a graphing calculator and those, it can only go a certain amount. It can't do all the numbers, can it? So if I've got all full 10 numbers here and I don't see any pattern at all, I'm going to say it's irrational. There's no pattern there, okay? So approximately 1.14213. Looking at the time here. I wanted to do something right now. Oh, you'll have homework.
What's it gonna be tomorrow?
Okay, I'll do this. I'll do what I was going to do tomorrow morning. We'll just finish this and you guys can work on the homework. All right, classify the following numbers. So I want you to take and decide what this number is. What is this equal to? Well, square root of 25 is 5, and this is equal to negative 5. So I'm going to look at my table up here. Where does it fall into? It's integers. It's an integer. It's also a what? Rational. And it's also a what? Real. It's not whole because it's negative. Okay? All right, square root of 361. Do that on your calculator. 19. So where does that number fit all in? Whole. It's a whole number, and it's an integer, and it's a rational number, and it's real. All of those. Square root of 301 on your calculator. Do it on your calculator. See what it looks like.
Ugly.
It's ugly. Kind of goes forever, doesn't it? And there's no pattern from what you can see. So I'm going to just list it like this. 17.349 ... Goes forever. So we can classify that as what? Irrational and real. They're all real. They're all real. Okay? All right, so I know we got one more thing to do here. Order the numbers from least to greatest. Hey, the best and easiest way to do this is put it into decimals. And I'm going to draw a number line. And I'll show you why. I'm going to put 0 in the middle. Okay, so take a look. The square root of negative 10. Do it on your calculator. What do you get? Square root of 10. Negative 10. So this is what it looks like. So I'm going to kind of put that on my number line. I'm going to put like negative 5 here. And I'm going to put this number about right here. But I'm going to write it below. And let me show you why. It keeps going. And that is actually this number. I'm going to put both numbers there. Because in your answer, you have to write the original form. Cool?
Yeah.
Okay. Now let's do 19 divided by 5. 19 divided by 5 is 3.8. So I'm going to jump over here. I'm going to put 5 about here. And I'm going to write 3.8 here, which is actually 19 over 5. The original form.
You might as well put -3 down too.
Yep. And then we can put -3 in, which is right here, about. And what's the square root of 100?
10.
10, right? So somewhere over here, I'm going to put the square root of 100. So these are the numbers in order, if you think of it as a number line. Okay? Those are the numbers in order.
Oh, that's cool.
You can rewrite them if you want. Okay, all integers, true or false? Last one, you guys, stay with me. Clark, is there a problem or you got it figured out? All integers are rational numbers. Is that true or false? Look up here. All integers are rational numbers. That's true. See, these fall into this category. Okay? So true. That was a long one.